Benzyne mechanism. Benzyne mechanism is operating when the aryl halide contains no activating group and in presence of strong base. Okay, it is interesting that the incoming group does not always take the position vacated by the leaving group. So that is usually the incoming group is always present at the place where the leaving group lives. So in order to identify the position where the leaving group live, we label this carbon as carbon 14. Okay, in presence of NH2 minus, which is a strong base, in presence in liquid ammonia, two products are formed. One is the incoming group attach the same position of the leaving group. Here, this is the carbon 14 labeled carbon. Then another product is formed, that is here NH2 and here is the carbon 14. So by looking at this compound, you can identify that this is not the SNAR mechanism or any other mechanism. So let us come to the mechanism. So the mechanism can be explained the fact that it involves elimination followed by addition. Here this reaction occur in two steps. First step is elimination. That is here are aryl halide in presence of strong base NH2 minus. Then HCl is removed and form an intermediate benzyne. This is benzyne plus NH3 plus Cl minus. Then step 2. This benzyne react with our nucleophile NH3. Then one H is attaching here and NH2 is attaching here. So there is since this is a symmetric intermediate, it is equal probability to interact this NH2 over here and here. So the product will be mixture of products, that is here NH, here NH2. Then next product is here NH2, here H. So in order to identify which position is attaching, if we label this carbon as C14, then here C14, then here C14, here C14 and here, not here, here C14. Okay. So if you look at these two products, you can see that here this is the normal product where here Cl is replaced by NH2. But here substitution is taking place at another carbon. Such substitution are called sign substitution. Okay. So let us move on to the evidences that leads to Benzyne mechanism. This is Benzyne mechanism since this step is the rate determining step, that is elimination. So this mechanism is called elimination addition mechanism. Elimination addition mechanism. Okay. So let us move on to the evidences that lead to this mechanism. First evidence is when either aryl halide contain two ortho substituent. Suppose we are taking aryl halide. This is aryl halide with two ortho substituent. So there is no probability of forming this benzyne ring. That is, if this is not an electron withdrawing group, the SNAR mechanism will not happen. So the probability will be the Benzyne mechanism. But here, since there is no probability of no chance for elimination, that is here another group is substituted already. So there is no formation of benzyne intermediate in either side. So this mechanism will not happen. Okay, this is one evidence. Then the next evidence is the formation of exclusively signed product. That is, in some cases like this compound OCH3Br. Okay, here we are taking KNH2 in liquid ammonia, and H2 minus will be the. So the exclusive product is meta amino anisole. Okay, OCH3. So this is exclusively signed product, signed substitution. That is, it has been known that in many years, aromatic nucleophilic substitution occasionally result in substitution at different position. Such substitution are called signed substitution. Okay. Then orthoamino anisole. This is what orthobromoanisole. When treated with NH2 minus, the exclusive product will be this meta amino anisole. So by this product, the benzyne intermediate formed will be what? Here bromine is the benzyne. We cannot form benzyne in this side because there is already a group. So the benzyne will be by the elimination of hydrogen from here. Okay, so OCH3, this will be the benzyne formed. Okay, here the attack of NH2 minus will not be equally probable from here and here, because it is not actually a symmetric benzyne. In earlier case, we have discussed a benzyne which is symmetrical, so that both normal product and signed products are equally formed. But here, the probability of attacking here and here will not be same, because we know that this OCH3 is a activating group, and if you look at the resonating structure of this OCH3, you can see that there will be a negative charge at ortho position and para position. So this nucleophile is already a negatively charged, so there will not be attack at here. So the exclusive attack will be here. Not only this electronic reason, but also steric, due to steric reason also, this will be the result. That is, exclusive product will be the signed product. Okay. Another evidence is that when we use different halides, the reactivity order of reactivity is Br greater than I greater than Cl greater than F. That is, here instead of this Br we are using different halides. Then we get the order like this. So since this fluoride substituted arraign is least reactive, it is clear that the reaction is not SNAR mechanism. The difference in this order is, that is, bromine is greater than iodine, is because when the leaving group is bromine or iodine, the proton removal is the rate determining step. Okay, when chlorine and fluorine is leaving group, the cleavage of CX bond is the rate determining step. That is why the order is like this. But the point I should mention is that the least reactive is fluorine, so that it is not SNAR mechanism. Another evidence is that this benzyne intermediate, or in general we can say that the arraine intermediate, even though it cannot be isolated normal condition, it can be isolated at argon matrix at 8 Kelvin. Argon matrix at 8 Kelvin. And it can be trapped by using Diels-Alder reaction. So that is, in case of Diels-Alder reaction, we should have two compounds, that is a diene and a dienophile. So this benzyne can act as dienophile. So let us have the reaction. For example, this benzyne, then here the shifting is like this, and adduct may be formed. Okay, so the formation of this kind of adduct is an evidence for the formation of this benzyne intermediate. Okay, this is one evidence, because here this new bond does not affect the aromaticity of this benzene ring, and this is actually this electron will be in pi bond, which is not in delocalized with this aromatic electron system, or aromatic delocalized system. This is not only the canonical form, but another canonical form may be that is like this, two double bonded like structure, that is like cumulated diene. Okay, this is another canonical structure. So this is structure A and B, but the contribution of this structure will be more as compared to this compound. Thank you.